So let's discuss some questions for Newton's laws. Right? So some students say me that they have asked me to discuss some difficult questions. So I have selected some questions, but I'll discuss two very simple questions before everything. After that, I'll discuss the difficult questions that they have said. Right? First one, find the acceleration. This is very simple. I'll start with the simplest possible question. There is an object. Mass is 10 kilogram. A force of 2 Newton is applied. So what should be the acceleration? So I'll start with the simplest possible questions. Draw the figure and find the acceleration. You can use linear motion mechanics. OA. Linear motion mechanics or any book where there are spaces. The first question is very simple. We want to find the acceleration. So you just want to apply F equals Mv. The force is 2, mass is 10. So what should be the acceleration? Just take 10 to this side. 2 over 10 equals A. Therefore, the acceleration is 2 over 10 means 0.2 meter per square seconds. That's it. So simple. Who got this answer? Right, that's it. So simple. Please be very happy. It's okay to be happy. Question number 2. Question number 2, please write. A rocket is moved vertically upward. Question number 2. A rocket is moved vertically upward by the vertical force. By the vertical force given by its engine. A rocket is moved up by the vertical force given by its engine. Given by its engine. If the force given by the engine is, if the force given by the engine is 12,000 Newton, 12,000 Newton, and if the force given by the engine is 12,000 Newton and the mass of the rocket is, and the mass of the rocket is 1,190 kilogram, and the mass of the rocket is 1,190 kilogram. Come on. Find the acceleration of the rocket. Find the acceleration of the rocket. A rocket is moved vertically upward by the vertical force given by its engine. If the force given by the engine is 12,000 Newton and the mass of the rocket is 1,190 kilogram, find the acceleration of the rocket. So this is the figure that you want to prove. But please remember that the rocket is moving up from the earth. So in addition to the force given by the engine, the earth gives a vertically downward force of mg Newton. Most of the students forget this mg. Most of the students forget this mg. And now try to find the acceleration here. So then what's the total upward force here? If ENG acting upward, NG acting downward, the total upward force, the resultant upward force is upward force minus downward force. So if I apply F equals NA upward, the upward force is FENG, downward force is MG. FENG minus MG is the total upward force, the resultant upward force. Mass of the rocket is given as 1,190 and I will find what the acceleration is. Am I right here? Correct or wrong? Force given by the engine is 12,000. Mass is 1,190. G is 10 equals 1,190 into A. 12,000 minus what is 1,190 that is 11,900. Am I right? With the when you multiply by 10 equals 1190. 12,000 minus 11,900 that is 100. So 100 equals 1,109 times A. Just take it to this side. Then you will get A equals 100 divided by 1,190 0 cancelled out. A equals 10 over 119 meter per square second. So you will get this kind of numbers in advanced. You will not always get 2 meter per second, 3 meter per square second like that. Who got this answer? Right. So when a rocket equation is given, if a rocket is moving up from the earth, do not forget this mg. Okay, dear? Complete. Example number 3. A metal box of mass 20 kilogram. A metal box of mass 20 kilogram. A metal box of mass 20 kilogram is kept on the floor of a lift. A metal box of mass 20 kilogram is kept on the floor. Is kept on the floor of a lift. Is kept on the floor of a lift. You know what a lift is? It's a metal box. It can be moved up and down by using an electric motor, right? That's it. Right? A metal box of 20 kilogram is kept on the floor of a lift. Full stop. The lift is moving up with an acceleration of 2 meters per square seconds. The lift is moving up with an acceleration of 2 meters per square seconds. Okay, dear? Draw the figure. After that, I am going to ask several questions range Roman number 1, Roman number 2, and Roman number 3. First, you draw the lift and the box. Roman number 1. What should be the acceleration of the metal box? Roman number 1. What should be the acceleration of the metal box? What should be the acceleration of the metal box? Okay. Roman number 2. Draw the free body diagram of the metal box. Draw the free body diagram of the metal box. Draw the free body diagram of the metal box. Roman number 3. Calculate the normal reaction force acting on the metal box. Calculate the normal reaction force acting on the metal box. Acting on the metal box. Okay. Final question. What should be the magnitude of the force? What should be the magnitude of the force given by the metal box to the floor of the lift, what should be the magnitude? What should be the magnitude of the force given by the metal box to the floor of the lift? To the floor of the lift. Okay, dear? Right. Look at board. What is the acceleration of the lift? What is the acceleration of the lift here? Acceleration of the lift is 2 meters per square second. The box is inside the lift. Therefore, what should be the acceleration of the box here? 2 meters per square second. So it's nothing, right? The box is inside the lift. Lift is moving with an acceleration of 2 meters per square second. Therefore, acceleration of the metal box should also be 2 meters per square second. Write the answer. Quick. And Roman number 2, it is asked us to draw the free body diagram of the metal box. So what are the forces acting on the metal box here? The gravitation attraction force mg and the normal reaction force r. That's it. So this is the free body diagram. When we draw a figure, when we mark all the forces acting on it, so that figure is said to be the free body diagram. That's it. Completed here. Okay, then how do you find the normal reaction force here? Find the normal reaction force. We should apply F equals ma to the box. Only to the box. Vertically upward, I can apply F equals ma. Upward force is the normal reaction force. Downward force is the gravitation attraction force. Mass of the box is n. The box is moving up with an acceleration of 2 meters per square second. So mass of the box is 20, acceleration is 2. Can you do the rest and find the normal reaction force here? Apply F equals ma and find the normal reaction force acting on the box. Minus m is 20, g is 10. 20 times 2, 40. So r minus 200 equals 40. If I take minus 200 other side, it will be positive 200. So r equals 40 plus 200. 40 plus 200. So what is r here? R is 240 Newton. So what is the answer? Right. My question is, who gives this mg force here? mg force is given by the earth, gravitation attraction force of the earth. Who gives this normal reaction force? R. R force is given by the surface on which the object is kept. The object is kept on the floor of the lift. Therefore, R force is given by the lift. Am I right here? So every action has equal and opposite reaction. Whose law is that? Newton's third law of motion. When the lift gives a force of R Newton to the box should give equal and opposite force of R to the lift. Okay, dear? Let's write that answer. That's the final equation. R force, capital R force is given by the lift, is given by the surface of the lift. Or the lift, simply say lift. R force is given by the lift. R force is given by the lift. Full stop. According to Newton's third law of motion, according to Newton's third law of motion, according to Newton's third law of motion, comma, the box should give equal and opposite force to the lift. According to Newton's third law of motion, comma, the box should give equal and opposite force to the lift. Equal and opposite force to the lift. Clear? Leave a line and write the equation. Therefore, the force given equation. Leave a line and write. Therefore, the force given by the box to the lift. Therefore, the force given by the box to the lift equals, you can put them right, equals capital R, another English mark and write 240 Newton. Another English mark and write 240 Newton. Okay, dear? Clear or not? The logic is this, dear. So this is the lift. This is the lift. I'll draw the two figures separately. This is the lift. I'll draw the dotted line. And I'll draw the box separate. I'll draw the box and the lift separate. Like this. Right? The lift gives a force of R Newton upward to the box. Then the box gives equal and opposite force of R Newton to the lift. Okay, dear? So they are known as, what are they called here? Action, reaction forces. Draw these figures here. These are known as action, reaction forces. Action, reaction forces. Forces always are as in pairs. The lift gives the force of capital R Newton to the box. Then the box gives equal and opposite force of R Newton to the lift. Action, reaction force. One R is acting upward, the other R is acting downward. Right? Question number 4. Anybody wants more time to draw the figures and write the things here? Right. Question number 4. It's very similar to question number 3, but there are small changes. Please write question number 4. A scale is kept in a lift. A scale is kept in a lift. A scale is kept in a lift. In a lift. Full stop. An object of mass 4 kilogram. An object of mass 4 kilogram. An object of mass 4 kilogram is kept on the scale pan. An object of mass 4 kilogram is kept on the scale pan. Right? The lift is moving up. The lift is moving up with an acceleration of 2 meters per square seconds. The lift is moving up with an acceleration of 2 meters per square seconds. Full stop. What should be the reading of the scale? What should be the reading of the scale? Right. Draw the figure. Draw it. all, we should draw the free body diagram. We should draw the free body diagram of this box. That's what you want to do. Right? If the acceleration of the lift is 2 meters per square seconds, acceleration of this 4 kilogram object should also be 2 meters per square seconds. Look at what here. I'll draw the free body diagram. Right? Gravitation attraction force acting downward mg, the normal reaction force. Now listen to me here. Now this 4 kg object is kept on the scale pan. The 4 kg object is now kept on the scale pan. Therefore, the normal reaction force is given by the scale pan. Am I right here? An object is moving with the same acceleration as the lift. Draw this figure here and apply F equals ma only to 4 kg object. That's what you want to do. Apply F equals ma equation to the 4 kg object. Find the normal reaction force, R force. Right, Balan? The upward force is R, the downward force is mj equals ma. So R minus m is 4, j is 10. Mass is 4, acceleration is 2. So R minus 4 times 10, 40, 4 times 2, 8. So what is it? R, 8 minus 40 goes to the other side as plus 40. Therefore, R equals 48 Newton. Who got this answer, Lamai? Right. Now we can draw the same figure. Right? You can go here. I'm going to draw the same figure like this. This is the lift. This is the scale pan. This is the scale. Right? Then look at both. Then this is the 4 kilogram object. Look at both. This is the 4 kilogram object. Look at both here. Force is given to the 4 kilogram object by the scale pan. R force is given by the scale pan to the 4 kilogram object. Then what does the 4 kilogram object do here? It gives equal and opposite force to the scale pan. That's what happened. Clear here? Is right. Capital R force. Capital R force is given to the 4 kilogram object. Capital R force is given to the 4 kilogram object by the scale pan. Capital R force is given to the 4 kilogram object by the scale pan. Full stop. Then equal and opposite force. Then equal and opposite force. Equal and opposite force is given by 4 kilogram object. Is given by 4 kilogram object. Is given by 4 kilogram object to the scale pan. Is given by 4 kilogram object to the scale pan. Clear? Leave a line and write star point. The force acting on the scale pan is its reading. The force acting on the scale pan is the reading. Is its reading. The force acting on the scale pan is its reading. Is its reading. Okay, dear. So this is the reading of the scale. So reading is the force acting on the scale pan, that is R. We have found R as 48 Newton. So the reading of the scale pan is 48 Newton. That's it. Write this answer and draw the figure also. If you draw the figure, it will be very easy for you to understand this. Right. So please remember that the reading of a scale is the force acting on its scale pan. So I would like to discuss some more questions for this section.